Okay, let's start with chapter number 1 then. So the basic learning objectives are these: understanding the basics of different number systems, and then also understanding about representing data and video streaming, digital data, representation in graphics, audio. So those are the things to be covered in this lesson. Okay. So basically, so you have a few mathematical stuff, therefore, so better if you can, yes, if you can take a piece of paper or a book and write down this, because we will do a lot of calculations. So first of all, we have to learn these 4 number systems: binary, octal, decimal, and hexadecimal. These are the number systems that we are going to learn: binary, octal, decimal, and hexadecimal. Right. Okay. So let's discuss. Okay. So I have already prepared one for local A levels. So I'll use the same one, same tude to explain this to you. So, but there are some singular terminologies. Just ignore that. So you can just write what you can write English one only, right? So can you see my screen?
Right. Yes, sir.
Okay. The first thing that we are going to learn, this is the prototype actually. The first example that we are going to learn is about decimal number systems. Decimal number system means the number system that we are going to use in our usual life, daily basis. So in this number system, the base is 10. So you have to write down these important terms. When it comes to decimal number system, base is 10.
10.
And not only that, so you have to write, you have to know these points and digits that we are going to use 0 to 9. So in this base, even though base is 10, you can't see 10 in digits because 10 will be constructed by using 1 and 0. Here, using 1 and 0 only 10 will be constructed. So you have from 0 to 9. So this is basically 0 to base minus 1. Understood?
Right.
0 to base minus 1. And okay, so I have a small abacus here showing the representation of this number, because this is very important to understand this number system. You can see, so this is 7832.324. So can you tell me the value of 2, the positional value of 2?
It would
What is
be 10, 2 to the power of 1.
2 to the power 1 or 2 to the power 0? So basically, it will start from 0, okay? 2 to the power 0. 2 to the power 0 means ones.
Oh,
You
sorry.
can see in this abacus, 3 into 1, this is ones. 3 into 1 is 3. 10 to the power 0, not 2 to the power, okay? 10 to the power 0. 10 to the, any number to its power 0 is 1. Okay? Then it is 10 to the power 1, 10 to the power 2, 10 to the power 3. 10 to the power 1 is 10. 10 to the power 2 means 10 into 10. 10 to the power 3 is 10 into 10 into 10. So the positional value of 3 is what? It is 10 to the power 1, which is 10.
Power 1.
Yeah. Positional number of 8 is 10 to the power 2. It is 100.
Right.
Right? Positional value of 7 is 10 to the power 3, which is 1000. Here then you have 3 plus 10 into 2 means 20. Here 8 into 100 means 8 into 100,
800.
800. 7 into 1000,
7,000.
7000. You have to add all together to find the value. 7000 plus 800 plus 20 plus 3, it is 7823. That's how you calculate this part, right?
Right.
7823. No, sorry, 23. 7000, 7823. That's how you calculate this part. Okay.
Yeah.
Then the decimal number. The decimal number will be started with the negative power. That means minus 1. 10 to the power minus 1 is 0.1 or 1 divided by 10. You can write in both format, 0.1 or 1 divided by 10. This is 10 to the power minus 2, 0.01 or 1 divided by 100. And 10 to the power minus 3 means 1 divided by 1000 or 0.001. Then value of this will be 0.324. You are reading like this, 0.324, not 324, okay? It's
Yeah.
0.32, 3 from this, 2 from this, and 4 from this, okay?
Right. Yes.
Right. Referring to the same number system, referring to the base 10 number system, can you write figures or can you write the same for binary number systems? Binary number system. Binary means base 2. So can you tell me the digits in binary number system? What are the digits?
0 and 1.
0 and 1. Yes, that is true. So what is the base? Base is 2. So then it is something like this. Here you can see in decimal number system, it always, it will be 10 times of the previous. 10 times of 1 is 10. 10 times of 10 is 100. 10 times of 100 is 1000. That is always 10 times. So in the other hand, 1/10. 1/10 means 1/10 or 1 divide by 10 is 100. Divide by 10 is 10. Divide by 10 is 1. Divide by 10 is 1 divide by 10. Then divide by 10 is 1 divided by 100. Likewise, this way, right side, it is dividing by 10. Left side,
Right.
when you go to left side, it is multiplying by 10. Same will be applied to binary number system. But it is not 10, it is base 2 no. So here you can see multiply by 10. 1 multiplied by, 1 multiplied by 2 is 2. 2 multiplied by 2 is 4.
4.
4 multiplied by 2 is 8. So it always doubles. So you know, so even RAM size, hard disk drive size, pen drive size, you have 1 GB, 2 GB, 4 GB, 8 GB, 16 GB, 32 GB, 64 GB, always double, no?
Yeah.
Similar to that in binary number system, it doubles the values, and that is how binary number system moves on. Okay. So in the other hand, it will divide by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So likewise, 1 divided by 2 is 0.5. Or you can write this as 1 divided by 2. Here then, so the next one is 1 divided by 4. Next one is 1 divided by 8. Or you can write as 0.5, 0.25, 0.125. Understood?
Yes, sir.
Right. In the other hand, octal number system, you have 1 to 7, and here you can see 8 times. 8 times of 1 is 8. 8 times of 8 is 64. 64 into 8 is 512. So in the other hand, it will divide by 8. 512 divided by 8 is 64. 64 divided by 8 is 8. 8 divided by 8 is 1. So here also the same. So when it comes to hexadecimal number system, it is 16 times. 1, 16, 2, 5, 6.
Right.
So likewise, it's move on. So other hand, so it's dividing by 60. Why you are using these special letters, A to F? What's the reason?
Because numbers above 10.
Yeah, here numbers about 10. Because if you are using 1, 0 here, it's confusing because you are using the same symbols. This symbol and this symbol, you are again using here. So that means you are not using unique symbols. That will confuse the value of these digits. Therefore, it uses a single digit, which is A. So A is equal to 10, and in the other hand, F is equal to 15, but nothing more than F. After F, you don't have anything. F, G, H, I, no, you don't have such things. Up to F, because 0
Right.
is 0 to 15. 0 to 15, that is the range of hexadecimal. And in hexadecimal, you have letters and numbers both. Okay, now you know the basics. So now I just want to focus in calculations. How do you calculate? How you are going to calculate? That is very important. Okay, let's say you have, let's write a question. Convert from decimal to binary, octal, and hexadecimal. Convert from decimal to binary, octal, and hexadecimal. Can you write down the same?
Okay.
I'll give a few questions. So first one, let's do small one, 25. Second one, 513. Third one, the fourth one, so I want you to convert this to base 10, from base 10 to binary, octal, and hexadecimal. Can you do it alone or do you need my help?
Sir, to octal, I never learned how to do from to octal.
Right. Okay.
Like in our school, I don't think there is octal for this next year.
Sorry.
Uh, I believe if I'm correct, but I don't think there is a octal conversion for the 2021 exam. Only decimal, denary, binary, and hexadecimal.
Uh-huh.
Yeah.
So you want me to explain the things or
No, sir. Octal is not coming, I believe so.
octal is not there?
Yeah.
That's totally okay because octal is not there. So that is basically how. So any number system you should know because you can't just drop octal and on
Yeah.
because this is one single mechanism. For whole you have same mechanism. So then even it is not there in the exam. So don't worry. So learning that will not harm. So that is
Yeah.
indeed required because that is not to learn octal. Learn that is to
No,
learn the
sir.
mechanism.
My doubt is how to convert.
Right. Your doubt is how to convert. Okay, basically. So the steps. First, what you have to do, uh, take the okay, take the integer part and divide by base. Then find the integer remainder. Find the integer remainder. Continue until all the digits, basically remainders, are in the intended base. So that is the basically that is the mechanism. First, you have to take the integer part. Right, take the integer part. For an example, let's write a number like this. Number like 17.3125.
Right.
Let's say this is an example. 17.3125. First, take the integer part. Or let's say it's not 17 point like 57.3, some number like this, and 57 is the integer part. First you divide by the base means if it is binary, octal, or hexadecimal, no matter what number system is, let's do in to binary. Let's convert it to binary first. You divide by 2 is the base in binary, then write the number, write the answer and the remainder. What is the answer? 52 divided by 2.
So 52 or 57?
20.
Is it 57 or 52?
Yes, sorry. 57 divided by 2.
28.5.
28. You are not going to write 28.5, okay? So that is the basic here. So
Right.
you are going to write integer part only and then write the remainder. So for an
Right.
example, think that you have 57 mugs or 57 caps. So you are going to divide this within two parties, between two parties. 57 caps are there. So each party will get 28. Each part will get 28. One will be remaining. So you are not going to divide cap to two parts and give one part to one team and the second part to another team. No, that is not going to happen. So assume you have 57 vehicles and you are going to divide it to two teams, two groups.
Right.
Each group will get 28 vehicles, but there will be one remainder. You can't give half a vehicle to one and another part to another team. So that is not good. So this is integer division. Think about integer part only. Don't think about decimal part. Okay, then you have to repeat this. 28 divided by 2. 28 divided by 2 is, yes, 14 and remainder, yes. What is the remainder?
There's no remainder.
No remainder.
0.
Yeah. 14 divided by 2 is equal to 7 and remainder is 0. 7 divided by 2 is equal to 3. Remainder is 1. 3 divided by 2 is equal to 1. Remainder 1. So when you get all the answers, in binary format means binary number system, valid digits are 0 and 1 only. 0, 1. If all the
Yeah.
remainders are in 0, 1, now no other remainder, no? All lines 0 and 1. Now you take from bottom to top. You start from this and go up. Let's draw an arrow.
Right.
You can write this. Huh? You can write this.
Yes.
So this one, it's question. Okay, this is what you are doing. Then what's the value? It is 111001. So that is the binary value. It is 111001. So but that this is equal to 57 only. Okay, this is equal to 57 in decimal. But what will happen to the 3125 part, the decimal part? There should be mechanism to convert that part as well.
Right.
What you are going to do is basically take the decimal point, then take the decimal point and multiply by the base. You are going to take the decimal point and multiply by the base, and separate the integer and continue until final integer is 0. Okay, this is for the decimal part. So this is for integer part, you divide and write the remainder. Decimal part, you take the 0.3125, 3125, and you are going to multiply that by 2. Okay, this
Right.
you have to take 0.3125, not 0 point, okay? 0.3125 multiply by 2. Then the answer will be 0 point. Can you tell me the answer? 0 0.3125 into 2?
6250.
625. 6250. So then again take this point part, separate the integer part, and again take the point fractional part and multiply by 2. Now what is the value? 0.625 into
12500.
1 point.
No, 12500.
Yeah, 12500 means 1.25. So you can write zeros in the end will not affect because that is decimal. Fractional points you can
Right.
mention any number of zeros. That will not increase the value or change the value. So don't worry about padding zeros. Padding zeros will change value in integer only. If you add padding zeros to here, that will change the value. But if you add padding zeros to this one, padding zeros to this one, that will not change the value. So similar to that, if you add leading zero to this one, that will not change the value. I think you know these rules, no?
The decimal one, no.
Huh?
I didn't know the decimal one, sir.
You didn't know the decimal one. Okay. So anyway, remember
Yeah.
this. You if you had leading zeros to this, it will not change the value. Similar to that, for padding zero, if you add here zeros to here after the decimal point, that will even not change the value. Which change the value. So if you add zeros to this part, it will change the value. Similar to that, if you add zeros to this part, beginning, that will change the value.
Sir, could you excuse me for 1 minute? Someone is at the door.
Okay. Okay, let's explain the next thing. You have to again multiply by 2, and then you will get, after multiplying by 2, then you will get 0 point, sorry, yeah, 0 0.50. Then again you have to separate this one, and then again multiply by 2. So it will give you 1.0. When you get 0, you can stop this operation, and then you have to take from top to bottom the other way. Here you have to take from top to bottom. Here you went bottom to top, and for the decimal one, you have to come top to bottom. And after getting that, so the value will be 111,001.0101 in binary. That is the complete conversion. Okay, so you have to separate these to two things. Integer part, take
Yeah.
separately, divide by the base and write the remainder. Then the fractional part or the decimal part, take separately, multiply by 2, multiply by the base, and then take the integer part out, and that integer part will create this decimal part in binary or any other number system.
All right.
Okay,
Yes, sir.
right. Then, so I think we can now try to convert these questions. So you better write down the note and then try to convert this. And that part, so you have to write down this one, okay? So it's very important thing. Adding zeros to left side of an integer will not change value. Here this will not change the value. Then add in zeros to right side of a decimal will not change value. So means 0.34 you can add 0 to end. But in other way, if you add zeros to beginning of or the left side of decimal, it will change value. Similar to that, if you add zeros to right side of integer number, that will also change the value. If you didn't know, you can write down that as well. Okay. And the same time, try to convert these numbers to binary, octal, and hexadecimal. So if you are converting octal, what is the mechanism? If you are converting octal, what is the mechanism?
Divide by
Divide
8.
by 8 and write the remainder. So in the other way, if it is a decimal, you have to multiply by 8 and write the integer part. Same mechanism, okay? Same mechanism. Try to calculate these four and give me the answers. Then we'll discuss that. So I'll give you 10 minutes to convert. Is it okay? 10 minutes to find out these answers. Can you find the answer within 10 minutes or you need more?
Okay.
Okay.